This is my class for Python. It's a GravMath calculator. So the methods are the identifiers, the what do you call um the input methods, the get methods, and then I'm sorry, not the get method, the the class object conductor. It's the constructor. So this constructor starts the the mass one, the mass two m's, and r is also a parameter for the self.r. And our first method, our first function is g equals the force um, of of gravity divided by mass one, mass two, and times r to the second power, returning g. And what we have to do is input the force for this to give our own g. We can do that, but we already know what g is from past times. Um, and this constant is of around 6.67384 times 10 to the negative 11th. We return this, and then calculate f is going to be um, in relation to um, this constant g. It'll be m1 times m2 over r to the second power. We can also calculate the work done, which is f times the distance. We can calculate u, which is um, the 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 work times the r. Right. And then we can calculate k, which is 1/2 two m's over r. And then we have the total energy, which is basically k plus u, but this is another way to calculate it. And if you want to calculate a satellite, what do you call it? A satellite velocity. This is also a way. This is m1 over r. Uh, you know, remember our kinetic energy formula is 1/2 mv squared, and then g times m over r is um like kind of accelerate like force over distance to the square root of, and we're calculating the velocity. So it's just a little bit of algebra. I can show you. So this is velocity. V equals m over r times g. And then this to the 1/2. And then what originally it was kinetic energy equals 1/2 times m times v um, squared. And so that velocity is calculated through that way, derived that way. Um, but yeah, this is an example of calculating your physics homework on Python um, before you make a mistake like through your handwritten work. I'm sure you still have to turn it in. And so we have a couple of problems.